Hi, this is the first video in a multi-video series covering basic calculus skills for AP Physics C. And in these videos, we're going to be covering over the relationships between position function, velocity function, and acceleration function, their derivatives and antiderivatives, how to work between those, and other basic calculus rules referring to sine and cosine functions, exponential functions, and so on. This first video, we're going to be covering over the relationship between the position function and the velocity function as they relate to instantaneous rates of change, right? So in algebra-based physics, we often consider velocity to be equal to your change in x over your change in time. However, in calculus-based physics, we consider velocity to be your dx dt. So what this dx represents is a really small change in your x over a corresponding small change in time, right? So we're not looking at like average velocity over an interval anymore. We're looking at the change at that moment, right? How fast is the particle moving at that moment, right? And there are a couple of rules for solving this, but the main one that you will be using, and this will be on your equation sheet for AP Physics C, is if you know a function's position, x of t is 3t squared plus 2t minus 6, there's actually a formula that you can use, and it's actually listed on this equation sheet right here. It's called the power rule right here. So it says that the power rule for taking the derivative of a polynomial is described as the derivative of x to the n divided by dx equals this right here, right? So whenever you have a polynomial written like this, the derivative of that polynomial is going to be n x to the n minus 1. And the variable x doesn't matter. It can be t, it can be theta, it can be anything, right? So in this case, if we want the velocity, we take the derivative of our position function, right? So then we're going to get v of t equal to 3 times 2 t minus 2 minus 1 plus 2 t 1 minus 1 minus 6 t 6 times 0 to the t0. And what we can do is we can simplify this expression. It's going to be 6t plus 2 and then 0 here. But for this constant, as you see, it's going to be t to the 0. And since there's no t attached to it, we can just say that it's going to be t to the 0 because that's an equivalent expression. And then you would multiply it by 0 because t to the 0, you wouldn't do that. And then it would just cancel out to 0. And then now you get your velocity function as 6t plus 2.